right, guys. Well, I'm in the same clothes I was in the last video. It's because this video shouldn't be too terribly long. We're going on to chapter 3.4, which is operations with rational numbers. So, um, in this section, operations with rational numbers and are discussed. A rational number is the quotient of two integers. So that's something divided by something else. A rational number is a number that can be written in the form a over b, where a and b are integers and b does not equal 0. So if I were to take let's say 5 divided by 0. Because 0, you can't break something up into 0 pieces. 0 is not a rational number. 0 is just an error on your calculator. So if you see a number that's divided up into 0 pieces, just know that it's not a number. So I'm not going to divide my $5 up between 0 people because that just doesn't work. Okay, examples of rational numbers. 3 divided by 4, or 3/4. So if you have 3/4, that's a rational number. Okay? -2 divided by 9. -2 divided by 9. That would equal a rational number. It may be a negative number, but it's still going to be rational. Rational just means it's realistic. It's rational. So, and 13 divided by -5, which I'm not sure what your answer there would be, but I don't think it goes on forever. Let's try that one. 13 divided by -5 equals -2.6. So it's a rational number. A decimal point is still a rational number. Now, it gets irrational. We'll get up into that here in just a few minutes. A mixed number can be written as the quotient of two integers. Therefore, every mixed number is a rational number. So if you had 1 and 1/5, it's still a rational number. Okay. Recall from section 2.6, a fraction can be written as a decimal by dividing the numerator of the fraction by the denominator. So basically 1/4 is 1 divided by 4, which in a fraction would equal 0.25. You can figure that out with your calculator. So to convert 3/8 to a decimal, read the fraction bar as divided. So it's just 3 divided by 8. So if you go 3 divided by 8 equals 0.375. To convert 6/11 to a decimal, divide 6 by 11. And that's the easiest way. That's the way that we usually do it anymore. So, every rational number can be written as either a terminal decimal or a repeating decimal. So, a terminal decimal would be 6.25 or 25 hundredths. Why is it called terminal? Because it ends. Terminal just means it ends. Now, if it's a repeating decimal, it goes 0.12, 0.1, or it goes 0.12, 12, 12, 12, 12, 12. Okay, and goes on forever. That's still a rational number. Now, the pattern in this number is one additional 2 follows each successive 2 or each successive 1 in the number. There is no repeating block of digits. The number is irrational. This number is an irrational number. So if there is no repeating blocks after it, it's irrational. So other examples of irrational numbers include pi. I'm sure you guys have heard the term pi r squared. That's pi times the radius of a circle squared, which you, of course, square the radius first and then multiply it by pi. But hopefully we'll get into that here in a little while. So, which is presented in chapter 7. Well, we might go to chapter 7 then, and it'll be up to you guys. Okay, and square roots of integers that are not perfect squares. So, pi is this big long number. We shorten it to 3.14. That is why March 14th is called Pi Day, because we just do 3.14 on pi, or the 14th of March. So we have, or you can do the square root of 7, which I don't know how much we've gotten into square roots. You'll learn them in school. You will be going over them when you get to college even. So square roots are, you can do them on your calculator. I am not sure. I think it's the caret button, which is the up arrow. So we go square root of 7 equals, this is an irrational number because it just goes on forever and it doesn't have a stopping point. Now, if you took we'll hit second and then the caret button or the up arrow right here, and we'll enter 16. And maybe that's not going to give me it. Well, 16 is a perfect square, so it should. Where else? Oh, I know where it is. It's the x negative, or the x2 button. So right down below the caret button. And that does the square root. So let's do 7 again. And that's what you get for the square root of 7. So now we're going to hit it again. We're going to hit the second button, and then we're going to go down to the button where it has x2, which is squaring button right there. And we're going to go square root. Then we enter 16, and we hit enter, and the answer is 4. That is because 4 times 4 is 16. And when you're going for the square root of a number, you are trying to find what times what equals that. And when you're not doing a perfect square, you end up with a irrational number. Now, I'm going to go over this one a little bit. So say we have the number 1/3. 1/3 is 33.333, and the threes keep going on. So all you have to do is write 33.3 and draw a line over it. And that means that the decimal goes on forever, but it's repeating, so it is a rational number. That's kind of why I like fractions, because if you take a fraction and you divide it up into three pieces and you have 1/3, yeah, you just got a fraction of 1/3. When you put it into a decimal, I have 0.33 or 33.33333. I prefer fractions. Anyway, I think it gives you a more accurate. Okay, so we begin the presentation of operations on rational numbers by adding rational numbers in fraction form. If an add-in is a fraction with a negative sign, rewrite the fraction with the negative sign in the numerator, then add the numerators and place the sum over the common denominator. Okay, so this is going to be a lot easier if you just use your calculators, but we'll do it by hand here. Okay, so we have negative 5/6 plus 3/4. Now we have to make the 6 and the 4 into the same number. So we're going to go down here and look for the least common multiple. So 6 and 4 will both go into 12. That's why they have a 12 down here. So you go and what you do is you have to multiply this 6 by 2 to get it to go to 12. Well, you have to do the same to the 5. You have to multiply the 5 by 10 or by 2. So it is 10. Now they just put negative 10 because what they did was they just took this equal sign and they put it up there, and the negative sign and put it up there. Because it's going to be a negative number anyways. So negative 10. Now over here, you had to multiply the 4 by 3 to get it to go to 4. So you have to multiply the 3 by 3 to get it, and it goes to 9 down here. So now your common denominator is 12. So you're going to put a 12. Now what you're going to do is you're going to take negative 10 plus positive 9. And negative 10 plus positive 9, your answer will be negative 1. Okay, so negative 1 divided by 12 equals, and now they just put the negative out here, and just put negative 1/12. Okay? And you can do that all with your calculator easily. And I don't want you guys to have to get exhausted with doing all the math by hand. Do one, maybe two problems, then go on. Just use your calculator because your calculator is a tool for getting math done faster. And if you don't understand all the steps, it makes nice for that. So let's just quick do negative 5 fraction button 6 plus 3 fraction button 4 equals negative 1/12. And that is the answer that we got, negative 1/12. Okay, so I'll let you guys do the how-to number 2. It's the same basic concept. These are on your calculator. They are right above the 8 and 9 keys. Use them, okay? Because when you get to college, you will do that. Okay, so pause it. Do this one too. Okay. How to simplify negative 2/9 minus 5/12. So rewrite the negative fraction with the negative sign in the numerator. So what it's telling you to do is um, you're going to put the negative up here, but we're not going to do that yet because we have to find the common denominator that 9 and 12 go into. 9 and 12 both go into 36. Okay, so our common denominator then will be 36. And then all we have to do is, well, what did we have to multiply 12 to get it to go to 36? We had to multiply it by 3. So we're going to multiply the 2 by 3, which would be, oh, no, wait, am I wrong? It shows negative 8. Maybe we had to times the 12 by 4, but if we times the 12 by 4, our answer would be 48. I'm not liking this. Do this problem if you can think it up, but I'm actually going to put this into my calculator and see. Okay, so let's go negative 2 fraction button 9 minus 5 fraction button 12 equals, I gave the answer negative 23 over 36. How did it get, oh, I messed up. Okay, let's redo this. I'm going to erase all this. Okay, I messed up. We did the 3 times, 12 times 3 equals 36. So we still have 36 as our bottom number. We're supposed to multiply the 5 because the 5 is with 12, not the 2. So we have to multiply the 5 by 3, which would be 15. Okay, so you're going to minus the 15. Then we had to take the 9 times 4 to get it to go to 36. So above that, we do 2 times 4, which would be 8. And when we tack the negative onto this, move it from over here because that makes it simpler. So now we go negative 8 minus 15, which when we are minusing a 15 to a negative number, we're just adding the 15 onto our debt. So we go negative 15, or we go negative 8, down another 15, or added 15 to it would be 23. So our answer would be negative 23 over 36. Like I just did it with my calculator because I made a boo-boo. That was a totally careless mistake on my behalf, but I don't want to go back and redo the whole video. So just learn from my mistakes. You always need to, if you're multiplying the 12 by 3, you multiply the 5 by 3, not the 2, which was because you're multiplying the 2 by 4 because you're multiplying the 9 by 4. Okay, so pause it and do all the rest of the work on yourself, your own. Okay, so pause it and try this one. Okay. So recall the opposite of the opposite or additive inverse of n is negative n. Okay, so remember when we're doing positives and negatives, the opposite is a positive and a negative. Okay, rewrite subtraction as addition of the opposite. The opposite of 10.3 is negative 10.3, or 3 and negative 10 and 3/10, but I'm just going to use points for now. The signs of the addends are the same. Add the absolute value of the numbers, attach the sign of the addends. So we have negative 2.8 minus 10.3, negative 2.86 plus negative 10.3. So our answer, because we're adding a negative and a positive, so we're just going to add them together and tack on the negative. Again, if this is confusing to you, use your calculators, because I want to get you guys up in math. Basically, and I did this on this last one, I added, I'm subtracting, but really I'm just adding on the debt. I say debt because if you owe your mom $5, and then you say, well, I'm minusing another $5, well, you're gonna owe your mom negative 10, and that's how that works. So a negative minus even a positive number will be a negative. No, it will even be more negative. Okay, you try it, pause it, and do these. Might have been a little bit confusing in that last section, but okay. Pause it and do these. 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 Okay. Again, I would just pause it and do these, okay? It says simplify negative 7/10 divided by negative 14 over 15. You can do all this with your calculator. If you want to do it by hand, you can break it down and do it by hand. You can figure out what the common, or actually you don't have to do common. You would take 7, because you don't have to do that because you're dividing. So you would take negative 7/10, so I would just divide it by negative 14 over 15. So over here, what they're doing, they take negative 7/10 divided by, or actually they took away the negatives because it's going to be a positive anyways, because it's a negative times a negative. So what they do is they do 7/10 times 15 over 14, because they flipped this, multiplying it by the inverse. So then you just do 7 times 15, 10 times 14, add a 0. Now, right here they show you going, well, 7 will divide into 14, so that will go 1, and that will go down to 2. Then 10 and 15, this will go down to 2 because 5 goes into 10 twice. 5 goes into 15 3 times, and they're taking 1 times 3 equals 3. And then you do down here, you go 2 times 2 equals 4. So you got the same answer as right there, but guess what? I find that to be a big waste of time. Use your calculators. Okay. Pause it and do these with your calculators. Is negative zero point 0.6 a solution to the equation? Okay, plug in negative 0.6. So you do 5.2 times negative 0.6. And yes, it gives you the correct answer. I'm all for doing that. Okay, guess what? Pause it and do these. Pause it and do these. Remember, if you have trouble, pause it and do these. Remember, if you have trouble, have your parents text me and say, hey, he's having trouble on this one. And I will go back and help you. But try to think of the answer first. Okay. Pause it and do these. 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 Okay. Pause it and do these. Oh, look at that. We're to the end of 3.4. Now I'm going to go fast through these. Pause it and do 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 these. Okay, now we are on to section 3.5, Order of Operations Agreement. We'll probably be doing the same thing we're doing basically. I think I'm going to give it a rest for right now. I'll make myself some breakfast. It is 5:12 in the morning. I think this is the last section in chapter 3. By this time, you guys are pretty much caught up to everybody in the school. There is some more algebra that I will get to in the next chapter because that's dealing with variables and stuff, which once we get through that, we're caught up. We'll go to chapter 4. Maybe I'll do 5, 6, and 7 just because. But you guys have a whole bunch of knowledge now, and you guys should be feeling like you're super smart. You should feel that way anyways, because all of you guys are. Okay, so I'm going to stop this now. You guys have a good day.